Hey everyone, welcome back to another episode of Ask GN, the first one for 2018. This is a series where we answer questions from viewers and readers. You can leave yours in the comment section below, or you can go to our Discord on patreon.com/gamersnexus to join the Discord and then leave questions in the Ask GN channel. We've got a few good ones this week about sort of predictions, which we try to stay away from, but predictions about how mining can damage or if it damages PC components. Talk about if it is possible to, quote, fry a system from user error with regard to thermals, and a couple of other pretty good ones in here as well, PCIe lanes, all of that kind of stuff. So before getting to that, this content is brought to you by the Thermaltake Flow RGB closed loop liquid cooler, which is a 360 millimeter radiator plus 3120 fans that are RGB illuminated. The Thermaltake rain fans at that. This is a 4.5 Gen Azetec pump, which is one of the faster pumps. You can learn more at the link in the description below. Quick announcement before the first question. We are going to be at CES in about 1 week's time. So we will be there. The event sort of starts pre-show on Monday-ish. There'll be a couple of meetings and pre-show announcements and embargo lifts, stuff like that. And then goes through about Saturday. So we'll be there for the event. We'll be meeting with pretty much every company that you can think of that visits CES from the computer hardware side, and a couple of other media outlets as well, folks that you watch on YouTube. So we'll have lots of content. Make sure you're subscribed and keep an eye out for all of that. It's a big show for us. We'll probably be doing 2 to 3 videos a day on news announcements while at the event. And if you see anything that you think is, so 2 things here I'd like to request from you. During the event, if you see anyone cover something or you see tweets from companies or whatever, Facebook posts by companies, if you see something really cool that we haven't already covered, tweet it at Gamers Nexus. That is where I am most likely to see it during the show, and we'll do our best to get over there. If you have, I guess that's the main thing really, is if you have requests, let us know, especially if it's before the show, because then I can plan it better. But we've got most of the schedule planned already. First question comes from Klust413, who says, what's your honest guess for the gaming versions of Volta release frame? Would late Q1 be likely? So, disclaimer here, I don't like to try and predict things in the market for releases. We really don't have that much more information than you. So all I'm doing here with Volta, in quotes, is I'm going to give you some general ideas of how NVIDIA launches products and generally when. But that doesn't mean they always abide by those timeframes. But that might be the one thing I can offer that you may not already know. So first of all, Volta will almost certainly have large parts of it grafted into the gaming architecture, which we think we know the name of it, but can't talk about that yet. But the gaming architecture is not going to be exactly Volta as we know it today. I don't know what's going to be removed and what's going to be added, but it would be reasonable to assume that NVIDIA is following the same design philosophies for the gaming architecture. That would probably include, for example, a focus on asynchronous compute performance. We saw a big uplift in Volta. I would suspect that'll carry through to the gaming cards. So that stated, being that this is not a direct V100 or the Titan V will not turn into an 1180 Ti or whatever. It's going to be modified in some form before then. But the thing I can tell you is that generally speaking, NVIDIA likes to launch in 2 primary windows. They tend to launch things either at GTC or thereabouts. That would be their trade show, the Graphics or GPU Technology Conference. That tends to happen in May each year, just before Computex. If they don't launch things there, they sometimes launch them near GDC, the Game Developers Conference, but a lot less often, way less often. I think it's happened twice in the last couple of years. So May would be the first window to look at for something like that, at least an announcement. Normally they announce, it's changed, it's kind of been alternating the last few years. They'll do a gaming architecture or a gaming card, and then they'll do a deep learning card or architecture. GTC has been trending more towards the business and enterprise side of things, so I don't know if we'll see the trend of gaming cards being announced there continue, but they do like to announce things either at their own show or at an event near a main event but tends to be their own show. So that stated, a direct answer to your question, I would say almost certainly not Q1, but this is me going off of just experience, not off of any special privileged information. So I don't know that much more than you. Q1 seems unlikely to me. I think a sort of mid-year launch is more realistic. Typically, NVIDIA looks at either just before Computex or just after for product launches. The GTX 1080 was something like May 23rd or something. It was right before Computex, and that tends to be what they do. So short of that, there's really only 2 launch windows for flagships that companies do. It's basically May or it's like August-ish. If it's not there, then they're doing something pretty different from normally. So yeah, that's what I got for you. March was a bit anomalous for NVIDIA. That was primarily because AMD launched Ryzen in March, so they wanted to put out a 1080 Ti because they had no competition for GPUs at that time. So they wanted to grab all that market share from new Ryzen systems. Next question, Sergio Gonzalez says, the mining of cryptocurrency can damage the PC parts if you work in the same PC and mining, ? So let's look at this from a perspective of why do components get damaged regardless of how they are used. Because it doesn't really matter that much what kind of workload they're under. They get damaged from heat. Heat causes a few things. Heat causes rapid degradation of parts. It is a catalyst. And heat also causes things like fires. So in extreme scenarios, you could have not a fire like a house fire, but a fire like a component, like a power component just popping. VRM pops, is kind of what you would say. So a good example would be a capacitor. Capacitors, a lot of them can take about 105 degrees Celsius. Some of the better ones might be rated for 10,000 hours at 105 C. Some of the cheaper ones might be rated at 5,000 hours for 105 C. These are real numbers for actual capacitors you find on boards. Some of the B3, actually a lot of the B350 motherboards use 5K capacitors that's at 105 C. So if you're running higher temperatures, doesn't matter if you're mining or not, for prolonged periods of time, you could be eating away at the lifespan of those components. You are far more likely to chew away at the lifespan of capacitors than a MOSFET, unless it's a bad batch of MOSFETs or bad batch of power components like EVGA encountered with their ACX cards a little over a year ago at this point. And that's unlikely, though. Generally, you're looking at other component failures. VRM components like chokes and MOSFETs can take 125, 150 C really before they start derating hard. So yeah, caps would be the thing to look at. And this comes down to how the cooler is designed. So each card's going to be different. Cards that don't have a good heatsink contact to those power components are going to be under a lot more duress. So if you have cards that you can adjust the fan speed to keep the GPU core temperatures low, they're not cooling the power components, you can still have a catastrophic failure. And when they fail, primarily will hinge on how hot those components get that are rated for lower temperatures, like capacitors. 105 C is relatively low compared to other power components. So it's not going to be an instantaneous failure. Another source of failure we've seen, so I was looking at some photos of mining machines that had burst aflame via Twitter. And if you look at a lot of those, they tend to fail from overdraw on the power cables. So that's a scenario where you are either exceeding the current rating of the power supply for that rail, or you are exceeding the current rating for what the gauge of the wire can withstand. If you're using, and this is true outside of mining as well. So if you're doing high-end overclocking with power mods or hard mods on the card, like we did with Vega 56, if you were to then take a smaller gauge wire that's not rated for as much current and plug it in, there's a chance you could burn out the wires. And hopefully you have a good power supply that can help deal with that sort of thing. But that's generally the type of failure you see is overdraw or power component failures. It is possible for the GPU or the memory to burn out, but unless you've modified the card in a way that has interfered with the contact of those components like HBM to the cooler, it's pretty unlikely. The card has protections to throttle itself once it gets warmer, unless you enter a runaway thermal scenario where you've got racks and racks of these things and they're in a high ambient operating environment, 40, 50 C. Unless you're in that scenario, power components are still where you'd look for a failure. And then after that, probably fans, depending on how many hours the fans are rated for. If you're running fans at high speeds for long periods of time, you're going to chew through their rated lifespan a lot faster. And when fans fail, other components will fail unless they have a mechanism built in to trigger a shutdown, which I can't name a card current gen that does that. So yeah, those are the main things that fail. It's a really interesting topic, and it's probably worth a completely separate video with some testing, because I've done some testing on this kind of stuff. So I will leave that there for sake of getting to other questions. And there's a lot I've left out here, and I'm sure there's stuff that I'm not thinking about right now that we could include or talk about in the future, but we gotta roll through some more questions. So if you are interested in that topic more, not just cryptocurrency mining, but hardware failure from load in general, let us know and we'll look into it. I'll note one more thing here. With regard to any amount of sustained load, whether that's 3D rendering or mining, you can stay a lot of the keep a lot of the negative effects at bay by modifying the card with just a simple power offset. If you tell it to draw something like 70% of its power, it is going to draw well below what it's rated to handle. Those power components should be, if you've left it unmodified and it's not a terrible, terrible cooler design, they should be fine. So if you are really concerned about your rendering machine or your mining machine or whatever with high thermal environments, if you're concerned about it burning up, consider lowering the power target, increase the fan speeds, make sure there's direct cooling on the back of the card or somewhere to get rid of radiative heat off the backside of it. And then you can, of course, tune clocks if you had to from there, but undervolting, of course, also an option, although that doesn't really work that easily a lot of the time, especially with NVIDIA cards, but easier to do through power play tables. So yeah, that's some basics for you. But the thing to take away here is that heat is the catalyst for everything bad in computers. Or unclean power, I suppose. You can pretty much solve all of the things you'd be concerned about with good cooling solutions and with good power supplies. And once you've done that, there's not much more you can do. If you have fire concerns, a good power supply will solve a lot of those, and cooling will keep the heat away, because heat causes fire. And it's not as literal as how high of a temperature do you need for metal to catch on fire, because it's really freaking high. It's more a question of what is catalyzing from that heat, what's going on, what chemicals are breaking down, what power components are starting to fail, and then what is their catastrophic failure mechanism? Is it popping? Is it like bursting into a puff of smoke and brief flame? They're pretty uncommon things. You don't really need to worry about them, but that would be kind of the catastrophic failure I think you're talking about. You don't really have VRM components when they fail. It's not like you start getting artifacting. You don't just start seeing memory artifacts or texture artifacts in your graphics. It just dies. It goes black, it dies, shuts down, whatever. There's no gradual failure of a VRM component. It's just gone. So that's kind of, I think that should give us a good starting place to look into more later. I really like that topic. A lot of what we do is based around it, like thermal testing, power testing. So I'd love to talk about it more. Next question is from honeyforce, who says, Steve, is it possible to irreparably fry a system through heat by gross user error, like not using thermal paste, forgetting to plug in a pump or fan, and then gaming? I'm pretty sure there are some built-in protections, but can't recall hearing a trustworthy answer. Not sure at differences between short and long-term exposure. Pretty sure there are average consumers out there who throttle for months before realizing they need to clean the heatsink, etc. So a lot of the previous answer feeds into this one, so that's helpful. But briefly, I've done a couple of these things in the past. A really common one is forgetting to plug in the SATA coming off of like NZXT Kraken coolers, because then your pump doesn't turn on. You notice fast, because it'll throttle hard, the tubes get physically hot to the touch, things like that. There are built-in protections. Not every BIOS and CPU behaves the same. You can often configure them, at least in the higher end boards. Common failure modes would be when TJ max is hit on the CPU, which would be your junction temperature maximum. That's what the J is junction temperature as opposed to case temperature. So this is more or less an inside the CPU temperature as opposed to an external probe or sensor. So junction temperature, when you hit max, 105C on X299 stuff, HCC, high core count CPUs, when you hit max on that, your motherboard will dictate, do I shut down or do I throttle? Oftentimes it's the latter, it's throttle. And so if it throttles, you're just going to lose performance, drop clocks hard. It'll go down to 12 and then 45 and then 12, 45 over and over and over again for the multiplier. And you'll notice that. Another option for failure is a thermal shutdown. That's just cuts off, goes black, that's it. So those are a little annoying for, even if you're an experienced user. I've had thermal shutdowns recently on production systems that I've used, and it's not always easy to troubleshoot it because it just goes black, so you don't necessarily know what caused it. You might think it's something else first. As for the question, is it possible to damage stuff through gross user error? Certainly it is. If you run a GPU is a great example because it will not cause the entire system to shut down unless there's something really wrong. So a GPU might be a scenario where maybe you reassembled your heatsink improperly, there's poor contact, something like that. If that is overheating and it's still trying to operate at full capacity, actually, okay, better example, the heatsink contact to the die is perfectly fine and it's keeping it cool, but something's wrong with the contact to the VRMs. There's no mechanism in there short of VRM throttling if they have something that will keep them cooler. As opposed to the core, if the core is running too hot, it will throttle itself to a point, maybe down to even 2D clocks if it gets bad enough. But the short of it is a GPU or a component like that is more likely to have some kind of frying, using your word, than something like a CPU. The motherboard VRMs could also be damaged. The damage tends to come in the form of loss of lifespan of things like capacitors, refer to the previous answer. But yeah, it's always possible to cause damage from heat. You try to avoid those scenarios, but also if you've already had a scenario where you forgot to plug in the pump for a while or something like that, I wouldn't stress about it. I mean, if you realize the error and fixed it and it seems like everything's okay, just move on. There's nothing you can do at this point. If some damage has been caused, you might not know for years if it was just a capacitor overheating or something like that. If serious damage was caused immediately to the component, you would know. You'd get artifacting, or you might not be able to sustain the overclock that you previously sustained. That's a pretty common one for people who overdo their system agent voltage, SA voltage, or also known as VCCSA. Or if you are running a B350 board with a high capacitor temperature, you'll eventually start getting degradation, or I should say high MOSFET temperature, get degradation of the overclock. So those are things to keep in mind as well. But yes, it's possible. It's just, you have to really do it pretty bad to have that happen. Quick note here, I wrote down a note for myself to address this one. So for our content, we were diagnosing the Titan XM, where I took apart two hybrid coolers, two liquid coolers during the diagnosis. A lot of people were like, there are two comments I wanted to address. One is, why did you destroy two perfectly good CLCs for this? And the other one was, why didn't you just weigh them? So let's talk about why did you destroy first. I did not destroy them. You can refill them. They're fine. Also, separately, that's kind of our job. There are a few reasons I would disassemble two liquid coolers. So the context here is we took apart two liquid coolers and measured the amount of liquid in them for a very quick ad hoc permeation test. It wasn't that scientific. And the reason you do that, one is so you have a baseline, you understand how much liquid are we expecting from a new unit. Two, let's say we thought there was a problem with the first one, and I just say, I think that it permeated, there should be more liquid. Well, if I'm wrong, odds are that is a specific enough test that someone else probably won't check it for a while. And you don't want to be wrong and have people believe something false or inaccurate about a company's product, because that's not fair. So it makes sense then to take apart a second one and sacrifice it, or in this case, just empty it and refill it later, to make sure that we're correct. At least sample size of 2 is small, but it gives you some redundancy just to say you did due diligence to make sure you're not hurting a product's reputation when it shouldn't be hurt. So that's part of it. The other part is, again, my job is to review components, not to amass them and use them personally. So it's not wasteful to take them apart. It's part of the job, and it's it's not like that component would have gone to you for free if we didn't do it. So it's really not any loss other than making sure the content's somewhat accurate. Next question: why did you not weigh it? Weighing the coolers assumes a lot of things. Primarily, it assumes that the manufacturing tolerance is very tight, no error. Because if we weigh them both empty, you're probably going to find disparity just in the radiator, just in the tank. The liquid is a mixture of glycol and distilled water. It's possible that those mixtures changed between runs. It's possible that really a lot of things. The cold plate comes from another supplier that's not Asetek or EVGA in that case. So that could have changed. The mass of that could have changed. There are a lot of really small things, and there's going to be tolerance for all of these, whether or not they actually change the run. Take something really minor. Look at Noctua. They had that fan controversy last year with the China versus Taiwan made fans. That was a color change, and it's because the factory ran out of pigment or whatever color for the first one, and they made another batch, and it was slightly off. That's just color. So that's why we don't. I didn't weigh it because didn't really need to. And also, side note, I need to see if the cold plate was gunked up or if there was gunk in the tubes or anything like that. Next one here, Mega Scrapper. What will happen if you use a modern desktop CPU without any heatsink? Will it thermal throttle aggressively, or will it simply refuse to turn on because there's no cooler detected? This was aggregated by Mark Wolf in the comments. So they will generally turn on. We've done it actually. Some motherboards do have pressure detection where they'll refuse to boot or shut down if inadequate pressure is detected. But we did this with Threadripper. We actually when we first got Threadripper, we turned it on without a heatsink so we could take a thermographic image of we had Sharpied it out, so there was no emissivity issue. But we took a thermographic image of the IHS, which allowed us to see which spots were active, which then allowed us to see which dies were active as opposed to the other two, which are silicon substrate interposers, and determine. Back then, the question was, are all 4 active, or are 2 of them what people call dummy dies, also known as silicon substrate interposers? And that allowed us to do that. So the answer to the question is you can still turn it on, but it will eventually shut down or get dangerously hot. And depending on where you are in the boot cycle, it might not protect you from that. Next question, Judas Iscariot says, it's kind of ridiculous that they're launching new products called Ryzen Plus or whatever that's effectively the same product but fixing the platform issues, memory compatibility, better clocks, etc. of their original Ryzen line. I wanted to address this one because I can understand product segmentation to a degree. It gets a little ridiculous sometimes. See NVIDIA with their recent data center decision. But this kind of product segmentation I wanted to talk about, even from our perspective, taking an existing product that you have and then trying to find a way to reuse it and build upon it makes a lot of sense. Fab plants can cost upwards of $5 billion. AMD is technically fabless now, so they don't have that cost, but they still spend a whole lot of money doing R&D. NVIDIA brags about spending $1 billion on R&D. You spend that kind of money, you can't just launch one product and move on. You're not going to profit on it. And take a micro look at it from our perspective. We do a lot of testing. There are times when, actually a lot of the time, you don't want to throw out all your data. So what do? Okay, we test all these GPUs for a review. So we have a review coverage piece we can do. And then maybe after that, we can do a separate overclocking piece. Maybe after that, we can do an SLI piece. And you can do stuff like explicit multi-GPU with 2 different cards. And you have all this comparative data that you kind of amass over time. So you're able to reuse large portions of that to get a profit on a huge upfront expense, which would be the initial review, because otherwise it's simply not profitable. And from a much larger zoomed out perspective, you're a company like AMD or NVIDIA or Intel, you have billions of dollars of expenses. Yeah, you probably want to launch an iterative step afterward, not just go full new architecture. And also keep in mind that fab process, the shrinks, the process shrinks are not as common as they used to be, and they're getting a lot more difficult. So if they want to stay in business, they got to keep launching product. Yes, it is. It can get to a point where it is anti-consumer, certainly, but that's not always the case. It's just you have to judge it product by product and make sure it's not something that screws you over. The real question is, does this version of the product add something meaningful over the previous version, and could they have added that to the previous version just as easily? Depending on the answer there, you can kind of decide. An example of segmentation that kind of makes sense is professional GPUs versus gamer GPUs, where you're dealing with things like certified drivers, professional support, and product segmentation specifically with high-end enterprise products to try and make back your money. Licensing fees do that to a degree as well, or licensing rather, not licensing fees. I don't like the idea of imposing a EULA to force users to use a product a certain way. Companies don't generally tell you how to use the product, but it's part of the game. Ideally, that particular part of the game doesn't exist, but there are reasons for this type of product launch to happen. And that's just, not taking AMD's side on it or anything, but just realistically, all the companies will need to do that. Just like, look at cases. 90% of the cases that you've probably seen in the last year share tooling. It can cost a company $600,000 to tool a case, and they got to make money on it. So they're going to do that by reusing that tooling a lot and changing the shell and the injection molding on the outside, or vacuum, or whatever they use. Let's do one more. Last one. There's a lot of good questions. I'll do two more. Quick one. David says, this might be slightly off topic. How does your usual upload look? I have the impression that a lot of the smaller YouTubers spend some time in the comment section liking and responding to comments after the upload. Is that true? I think objectively you can look at it and it's true. We do it for a few reasons. One of them is because I like to try and encourage interaction in the community that is hopefully more meaningful than just memes and jokes, things like that. I try to keep the signal to noise ratio as clean as possible, and as you grow, it's more and more difficult to do that. And I'm okay with chasing away people who don't really belong here if that means we can sustain a community that is more mature and more focused on product analysis and development and engineering and all that stuff. I'm okay with making sure our audience is focused there, and being in the comments helps a bit. It also gives us ideas. It helps me know if we need to make a correction or anything like that. But yeah, we spend some time there. The next one, there are so many options. Okay, so let's do this one quickly. Ryan Frick says, are number of PCIe lanes available a limitation of the CPU or the motherboard? Bitwit and Paul made a comment in passing about the Ryzen 400 series chipsets possibly supporting more PCIe lanes. I thought Ryzen CPUs were limited, had less available compared to Intel processors. Very, very quickly, because I don't want to spend a lot of time on it at this point, but we'll talk about this more in the future. Very quickly, the CPU and the chipset both have PCIe lanes. For 400 series chipsets, what Paul and Kyle were talking about, I didn't watch it, but I would assume they were talking about the PCI SIG changes to the 400 series chipset. Those would include moving the general purpose PCI Express lanes. These would be lanes you can assign to anything as a motherboard maker. It is your choice to say, you know what, let's pull these 4 lanes off and give them to a gigabit Ethernet controller. Let's pull, it might not take 4 lanes, but just an example. Let's pull these lanes and give them to M.2. Let's pull these, give it to U.2. Pull a whole bunch of them, give them to SATA Express or whatever. So it's their choice. 400 series is going to generation 3 for the general purpose lanes. I think there's 8 of them, as opposed to generation 2. So they are going to be roughly 2 times the bandwidth per lane, and therefore you could pull half the lanes to achieve the same thing as 2 times the lanes previously. So if previously you needed, as a motherboard maker, 4 lanes to achieve a certain speed on your M.2 device, now you can pull 2 Gen 3 general purpose lanes and achieve the same speed. So that's the change that's happening. Lane count is primarily dictated by the CPU. That is what communicates directly with the PCI Express bus and its slots that are hosting your graphics devices. And that's dictated by the CPU. It also has some Generation 2 lanes, depending on which one you're looking at. The PCIe lanes on the chipset go to all the other high-speed I/O devices, HSIO as Intel calls it. And those are divvied up in a lot of ways, but for Intel, the PCIe lanes on the chipset can never be assigned in greater than groups of 4 to a particular device. So you can't assign chipset lanes to a graphics device and have it be by 8. It would have to be by 4, which means that if you're powering Crossfire, you're fine, but if you're powering SLI off of a Z200 series CPU, which has, I don't even remember right now, but 24 lanes, I want to say, something like that. It's off the top of my head, but it's not 32 lanes basically. So you would have to do a non-SLI. You'd be limited at 2 cards for SLI. You can't do by 4 for SLI. But that's the very basics of it. There's a lot more here as well. I'll save the rest of these questions and we'll do another one. Maybe we'll do 2 this week or something. CES is coming up after all. So thank you for watching. As always, you can subscribe for more. If you'd like to help us out directly, you can go to patreon.com/gamersnexus, or you can go to store.gamersnexus.net/modmat to pick up a mod mat like this one. I'll see you all next time.